Well, students, now we come to the discussion of series resistance. You see, in series, when we put the resistances come like this, one after another. But that doesn't imply that always resistances should be put one after another to be in series. The primary criteria that the resistances in series should be the fact that same current should flow through them. So whenever we have a situation when same current is flowing through the resistances, they should be in series. It doesn't matter when they are placed one after another or one if they are placed like this. Say my dear students, they can be placed like this as well. But now let us consider that how can you say that these two resistances are in parallel? Well, if I insert a battery here, so when I insert a battery here, what happens is that, as you can see, the current starts flowing and you can see the same current is flowing to the two resistances. So these two are in series. So the primary aspect of series resistance is the fact that the same current should flow to them. Well, let us come to the next discussion. The next aspect of the resistances in series is the fact that the total voltage across the three resistances should be equal to the sum of the individual voltages across the resistances. Say the resistance here is V1, and then here it is V2, and then here it is V3, like that. So if I go on adding V as V1 plus V2 plus V3, then I find that all these three sum to this V. And as you all know, V is equal to I into R. So we have I into R, then it is I into R1 plus I into R2 plus I into R3. So that makes R is equal to R1 plus R2 plus R3. Now students, let me tell you one more aspect of parallel series resistance. Now say for example, if I have a circuit like this, then I hope you understand that this R1 and R2 is in series. Why? Because the same current is flowing through them. So this has to be made clear that here the resistances are R1 plus R2 are in series. But dear students, if the circuit looks like this, then what? If the circuit looks like this, then what? Say for example, I have a circuit like this, and like this. So what I have here is the two currents flowing in a particular direction, and if they are equal, then they get nullified here. So this is a circuit where there is no current flowing. If the two resistances, internal EMF of the two cells are same. But if one is greater, then it will push through the other and flow the current in the same direction, making these two resistances again in series. So that it is one important aspect in series, that if we have EMFs like this, say if they're greater, then we are simply allowing them to flow in a particular direction. And if they are smaller and bigger like this, then the greater should prevail. So we will consider these two resistances in series with the EMF values having a net value of the subtraction of the two. So now we come to the last aspect of resistance in series. The last aspect of resistance in series implies the fact that whenever you consider resistances like this, see for example you have like this, like this, like this, like this, it goes on adding. Then say for example I have 2, 2, 3, again 3, again 3, again 3 and so on. So this makes to 4 and again this makes to 12. So 12 and 4 is 16. So as you can see, the equivalent will be always greater, if not much greater, than the highest value that they possess here, which is equal to 3. So in parallel, what we saw is that the equivalent was smaller than the lowest value, and what we see here is the equivalent is greater than the greatest value. That's all for now, students. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.